Okay, let's talk about long sensory pathways and answer the questions. What are the different types of somatic sensation? What tracts convey somatic sensations to the brain? And what are the ALS and DCML systems? Hello, everyone. My name is Dr. Morton, and I'm the noted anatomist. So, first of all, sensation is the awareness of a stimulus as a result of its perception by sensory receptors, which then send that message to the brain, specifically the post-central gyrus of the primary sensory cortex of the parietal lobe. So a receptor is stimulated, that sensation is relayed by neurons to the spinal cord, then to the thalamus, then to the cerebral cortex where shing, consciousness is perceived. Let's do it another way. If the X in this picture represents a nerve lesion, then identify the symptom or symptoms this patient would most likely present with. Well, that is the dorsal root ganglion, which means that's a dorsal root. They only contain sensory neurons, so if you knock out the dorsal root, you knock out all sensory neurons, and therefore sensation is lost from that side of the body, from that segmental level. Now, what do we mean by sensation? Somatic sensation now can be divided into the following different sensations clinically: vibratory sensation, proprioception, fine discriminative touch, pain, temperature, and crude non-discriminative touch. So first, what is a receptor? Well, it's a transducer. Now, that term, you probably know it, you just don't know it. Or things like, solar panels on your house that converts light energy from the sun into electrical energy, or a windmill, which converts wind energy that turns a combine and converts it into electrical energy. So a transducer converts a non-electrical stimulus into electricity. So things like light and vibration, so if you have photoenergy that hits your retina and that's turned into a neuronal action potential, or a vibration that hits a part of your tendon and then that's turned into an action potential. So there are 5 different types of receptors in the body: mechanoreceptors that measure movement, nociceptors, which are for pain, thermoreceptors that measure for temperature, chemoreceptors that take chemicals and convert it to an action potential, and photoreceptors that convert light energy into an action potential. Now, when it comes to long sensory pathways, we just focus on these top 3. Some receptors are specific to single modality and some are a combination. So an example, asterognosis, is when you reach into your pocket and you feel your keys. You can't see them, but you feel it's cold. You feel the sharp and rough and sharp, smooth edges, and you can recognize it's hard or soft. So there's more than one sensation that lets you know what it is. Now, sensation. Here we've got each sensation is transmitted by sensory neurons, these sensory neurons through the dorsal root. Now, what part of the spinal cord is utilized for these sensory pathways to reach the cerebral cortex? And the answer is spinal cord white matter, these ascending tracts that go up. So in a nutshell, spinal cord white matter transports somatic sensory input up to the cerebral cortex. Now, why do we care about the different types of sensation? Well, the spinal cord white matter contains 2 major ascending pathways for somatic sensation. One is called the dorsal column medial lemniscus, and the other is called the anterior lateral system. So when we see the dorsal column medial lemniscus, there it is. It's in the dorsal column of the spinal cord, and it's transporting vibration, proprioception, and fine touch up the dorsal column. And so we see that all those sensory neurons go through the dorsal root, but then they ascend in the ipsilateral, same side, spinal cord white matter. In contrast, the anterior lateral system gets its name because it's going up the anterior and lateral parts of the spinal cord white matter. And it specifically deals with pain, temperature, and crude touch. So those sensory neurons all are going to then enter also through the dorsal root, but they're going to ascend in the contralateral spinal cord white matter. So vibration and proprioception and pain and temperature. Hey, why didn't you include fine touch and crude touch? Well, touch is subjective. Patients may not know how to explain the difference between them. So it's not that they're not important clinically, but I'm going to focus on vibration, proprioception, pain, and temperature. So let's blow this up. So there's the dorsal column. That's vibration proprioception ascending from the same side. And there's the anterior lateral system for pain and temperature from the opposite side. This is what's called sensory dissociation, where pain and temperature pathways ascend in the spinal cord separately than vibration and proprioception. Now, how many neurons do the DCML and ALS systems use to get from the skin to the cerebral cortex? Like that. This is a 3-neuron pathway, a first, second, and third order neuron. Sensation goes in a first order neuron, second order neuron, and a third order neuron. The first order neuron cell body is in the dorsal root ganglion. The cell body for the second order neuron is in the spinal cord or spinomedullary junction. And then the cell body for the third order neuron is in the thalamus. There's a decussation that occurs somewhere in all second order neurons. Now, that term decussate is where axons cross from one side of the brain or spinal cord to the other. And this word decussate is Latin for mark with a cross, because the Roman numeral 10 is deca, as in X, which shows crossing from one side to the other. Now let's go over the anterior lateral system and dorsal column medial lemniscus individually. So let's first start with the ALS, shall we? Also known as the spinothalamic tract. This is going to be for pain and temperature pathway, and there's 3 neurons, first order, second order, and third order neurons. But I'm going to draw them this way, okay? Where the first order neuron, it's coming from somewhere in the skin. In this case, I'm doing it the skin over the medial malleolus. And then I'm going to take this pin and poke the skin. And that primary order neuron is going to enter through the dorsal root and go into the dorsal horn, where that second order neuron decussates in something called the anterior white commissure, to the contralateral side of the spinal cord and ascend in the anterior lateral system to synapse in the thalamus, where a third order neuron will course into the cerebral cortex. Now, why is it called the anterior lateral system? Well, there's the anterior lateral system. It's located in the anterior lateral portion of spinal cord white matter. Why is it also called the spinothalamic tract? Because part of the tract courses from the spinal cord to the thalamus. Okay. Now that was fun, wasn't it? Let's do it again. So here we're going to show this illustration that I did, where there's the cerebrum and there's the thalamus, and then midbrain, pons, medulla, and then there's the cervical, thoracic, lumbar, and sacral spinal cord levels. Now what we're going to do is take a cross section through the lumbar, and one through the thoracic, and one through the cervical, and also in that spinomedullary junction, and then a cross section through medulla, pons, midbrain, and then a coronal section through the cerebral cortex and thalamus, and show right and left sides. And that's the model we're going to use to relay the pain and temperature. So there's our 3 order neurons. But now we're going to do it again, where there we have primary neuron in the dorsal root ganglion going to the dorsal horn like this. Ouch. Okay. And we're poking for pain. So there's a primary order neuron that courses to the dorsal root ganglion where the cell body is, synapses in the dorsal horn, and then that second order neuron is going to decussate at the anterior white commissure, go through the spinothalamic tract, and synapse in the thalamus. So there's the second order neuron cell body in the dorsal horn gray matter. It decussates at the anterior white commissure and then ascends in the spinothalamic tract all the way through the brain stem, and then synapses in the thalamus. And from the thalamus, that third order neuron goes to the primary sensory cortex. Third order neuron courses through the internal capsule and then synapses in the postcentral gyrus of the cerebral cortex. So what we're going to do is I'm going to take a little bit of a tangent and talk about something called the sensory homunculus. It's a distorted brain map of sensory distribution of the human body. And there you can see the foot and going up to the leg and the trunk all the way up to your upper limb and hand and to the head, face, tongue region. larger parts of the homunculus show more complex innervation, so the amount of cortex devoted to body region is not proportional to its associated surface area. So for example, you see how big the hand is compared to how small the foot is? That's showing that there's more complex innervation in the hand than in the foot. So there we see that the sensation is on the medial malleolus, and that's why the sensation is going to the medial part of the longitudinal cerebral fissure, like is shown there. It's like a map. All right, so there we have it shown in 3-order neurons, and there we have the 3-order neurons demonstrated. Now there's something here I put up the Tract of Lissauer that I'm not spending a lot of time on, but I'm going to spend some time. Okay, so here we have skin, and there's pain and temperature for if primary order neuron comes in, synapses in the dorsal horn, and a second order neuron decussates to the opposite side, and it's going to continue up. But there's something called the Tract of Lissauer, or dorsolateral tract. And this is where central processes of first order neurons may branch within this Lissauer's tract at the tip of the dorsal horn, and then that central process can ascend or descend in Lissauer's tract for 2 or 3 spinal cord segments to synapse with second order neurons in the dorsal horn of a superior inferior adjacent spinal cord. So let's do that again. So there's a primary order neuron from L4, and when it enters, instead of synapsing, some of these central processes ascend up to a superior segment and then synapse with a second order neuron in a superior level of the spinal cord. But take a look what also happens below, in this case the L5 level. That primary order neuron enters Lissauer's tract, and then it ascends up 2 segments to synapse in the L3 segment with that second order neuron. Now, why should we care about this? Well, if we have a lesion right there on the L4 spinal cord level on the anterior lateral system, the sensation from that level and perhaps the level below may remain intact, because Lissauer's tract allows that sensation to ascend up 2 or 3 segments. Does that make sense? All right. Now, let's do some practice time for ALS. Where would pain and temperature sensory loss occur if the left anterior lateral system and the L4 spinal cord region were damaged? So there we've got it right there. And so I'm going to go and answer this, but you may want to take a second to think this over. But if we see sensation from any level below that, it'll go up. It cannot get up because there's a lesion in the anterior lateral system. But now let's go from the cervical region. Watch what happens from the contralateral side. Sensation has no problem coming in, either from the T4 level, but what happens at the L4 level is some of that material, that sensation will not make it, and definitely from the sacral region will not make it, like that. So pain and temperature from the contralateral side of the body at or below the lesion cannot make it to the brain. And if the brain cannot perceive the sensation coming in, that input, then the brain does not recognize sensation occurred. So if the sensation's in the left anterior lateral system, then we'll have right-sided loss of pain and temperature at and below that level. Let's do another one. The indicated region has no pain sensation. Vibratory sensation is unaffected. Identify the part of the CNS most likely damaged. Well, I'm going to give you these choices and pause to answer, but I'm going to go ahead and answer. So sensation, loss of pain and temperature on the left side of the body. And so the lateral medulla conveys pain and temperature sensation from the contralateral side of the body. And so A would be the best answer. That is the best answer as shown here, because skin for pain and temperature from the contralateral side of the body ascends up the anterior lateral system to the medulla, like that. The cervical region from B and E are not correct, because B does not, at the C7 level, does not include, based upon the dermatomes affected, enough segmental levels, and E is on the wrong side. C is showing not enough dermatomes on the right, and left is the wrong side. Okay, all those are the wrong side. Whew. Take a breather, stand up, crack your knuckles, and let's go to the dorsal column medial lemniscus, which is vibration and proprioception pathway through 3 neurons, 1, 2, and 3. And so we're going to show the same coming from the medial malleolus, the L4 spinal cord level, but instead of a pin for pain, we're going to do a tuning fork for vibration. And that primary order neuron also enters through the dorsal root, but then that dorsal column is where that neuron ascends to synapse with the second order neuron in the spinal medullary junction, and then to ascend up contralaterally to the contralateral thalamus, where third order neuron will go to the cerebral cortex. Now, why is it called the dorsal column medial lemniscus? Well, that's the dorsal column of the spinal cord, and the medial lemniscus is Greek for ribbon, because in the brainstem, the ascending neurons altogether spiral like a ribbon. It's quite pretty, actually, like that. Now, that was fun. Let's do it again, except with more detail. There's skin. And when vibration or proprioception are stimulated, those primary order neurons enter through the dorsal root. There's the cell body for the dorsal root ganglion. They're going to ascend and synapse in the spinal medullary junction like this. So there we're going to put vibratory sensation on the medial malleolus, and a primary order neuron will enter through the dorsal root ganglion, and then in the dorsal column ascend up that ipsilateral side, still the primary order neuron, in the gracile fasciculus. But there's also the cuneate fasciculus. And then I'm going to talk about those in a second. And that primary order neuron is going to synapse in the gracile nucleus, but there's also a cuneate nucleus. What's the deal with those? Well, let's take a second and blow that up and talk about it. The gracile fasciculus is a part of the dorsal column, and gracile is Greek for slender, like the gracilis muscle in the medial part of the thigh is very slender. And fasciculus means bundle. So this slender bundle is going to transport primary order neurons that are carrying vibration and proprioception from below the T7 spinal cord level up to the spinal medullary junction. Specifically, the gracile nucleus, where the synapse occurs. Gracile fasciculus synapses in the gracile nucleus. The gracile tract is identifiable on every section of the spinal cord. Now, in contrast, the cuneate fasciculus, which is Latin for wedge and bundle of wedge-shaped axons, transport vibration and proprioception from above the T6 spinal cord level. And then those primary order neurons synapse in the cuneate nucleus. And the cuneate tract is identifiable only on the upper sections of the spinal cord above T6. So there's those two fascicles, which together make the dorsal column. And the gracile nucleus and cuneate nucleus are the cell bodies for second order neurons, between the synapse between the first and second order neuron. So there's that spinal medullary junction. So now that we have this cuneate nucleus, or gracile nucleus, that second order neuron is going to then decussate at the spinal medullary junction and then ascend in the medial lemniscus to synapse in the thalamus. So there's that second order neuron. It's going to decussate at the spinal medullary junction and ascend in the contralateral medial lemniscus all through the brainstem and synapse in the contralateral thalamus. Then the third order neuron is going to ascend to the primary sensory cortex. So there we have the cell body in the third order neuron. It ascends up through the internal capsule and synapses in the postcentral gyrus. And there we have all of them. I want to make a note here, like a little caveat. Somatosensory information is, oh, hey, Gabriel. Sorry, my son Gabe just brought me very tasty sorbet. It's like, I think it's mint. No, sure, it's lime. It's very tasty. I thought I'd share that with you. Now, the little caveat here is somatosensory information involved with proprioception and posture is also processed in the cerebellum. And we have these spinocerebellar tracts are going to come, and it helps to ensure that where our limbs are in location are actually perceived where they are at. But I'm going to leave that for another video. All right, so there's the dorsal column, medium lemniscus, all three order neurons. So let's do a little practice time, shall we? Where would vibratory sensory loss occur if the right DCML at the L4 spinal cord region were damaged? Okay, there. So pause the video, but I'm going to go forward. So ascending information on that ipsilateral side is going to be problematic. But we see that ipsilateral information on rostral spinal cord segments are unaffected, but at the level and levels below are all going to be affected. So vibration and proprioception from the same side of the body at or below the lesion cannot get to the brain. And so if we're on the right DCML, we are going to then lose vibration and proprioception on the right side of the body from that level and down. Does that make sense? Let's do one more. The red shaded region of the spinal cord is injured. Identify the letter that most likely demonstrates loss of vibratory sensation in this patient. Well, here we have a bunch of pictures. So pause, but I'm going to go forward. So the correct answer is D. Now, I know this is a thoracic spinal cord level because there's a lateral horn for preganglionic sympathetic neurons, a very small gray matter ventral horn because the intercostal and abdominal muscles do not require a lot of motor neurons, and there's quite a bit of white matter. So we know this is thoracic. Now, A is wrong because it's showing dermatomes that are lost in the cervical region, and this is a thoracic level. B is incorrect because it's showing only a dermatome probably from the C7 level that's injured, and this is white matter, so far more dermatomes are affected. The C is incorrect because it's also showing only one dermatome that is affected. And E is wrong, so even though it's a dermatome in the thoracic region, it's only one dermatome, because the white matter is affected, there'll be every dermatome below that would be injured. So there we have it. Okay, injured spinal cord. Now, what we're going to see in this case with a hemichord or Brown-Séquard syndrome is the injury is on half the spinal cord. So they will have loss of vibration and proprioception from the ipsilateral side of the body at and below the spinal cord lesion. However, they'll also have loss of pain and temperature from the contralateral side of the body at and below the spinal cord lesion. And what do we call this phenomenon? Sensory dissociation. Remember we talked about that before? Okay, let's do one more example. The indicated region has no vibratory sensation, as shown here. Identify the part of the central nervous system most likely damaged. And here are the choices. Pause, but I'm going to go forward. So what we see here is the left side of the body, from cervical region all the way down, has lost vibratory sensation on the left side of the body. And because it's on the left side of the body and it's vibration, that will be from the left side of the spinal cord and not brainstem, because the brainstem is going to be from the opposite side. So it'll be the left side. So vibration from the same side of the body at or below the spinal cord region. G is the best answer here. As shown right there in red, where you see the lesion on the left dorsal column, showing that all sensation from the C4 spinal cord level down on the left side for vibration and proprioception is lost. Okay, so here is a synopsis of the dorsal column medial lemniscus. Here is a synopsis of the anterior lateral system. And that, my friends, are the long sensory pathways in a nutshell.